feel like I know where she is. Oh, yes, I do. Did they say yes or no? Or?
They said no because I left on, or like because of opportunities, but I left a lot because of like anxiety.
Yeah.
So like.
It's just so many periods absent doesn't count. So, all right. Is this where we left off, guys? Okay, we're gonna talk about this because I didn't realize this yesterday as we were doing it. But this first one on worksheet 4B, it said you borrowed $4,000 at 6.2 for 8 years simple interest, remember? And we owed a total of, or it doesn't say borrowed, so maybe it's an investment. But anyways, it turned out to be $59.84 with interest. Number 2 was the same. I didn't realize that, but it's compounded monthly. So that one we did yesterday, and it turned out it went up to $65.60. And then I think we skipped number 3, but number 3 is part of that same package in terms of it's still $4,000, but it says compounded continuously. How does that work? What formula are we using for continuously? PE to the RT, PERT. Remember that one? If you don't have your sheet out, take it out. E to the R is the rate, and you do have to move the decimal over because we're not using the app, times T, which was 8 years. So that's a big old multiply by 8. I don't have this on yet. $4,000 second ln to get e to the 0.062 times 8. Did I remember that right, guys? And it is very close to what we had for monthly, isn't it? Is that what we had right above it was 65.60? It's second ln. Natural log down at the bottom. Got it? Okay, so this was 65, 68, and how much change? Anybody still got it? 56 cents? Okay. So notice simple interest was the cheapest by quite a bit, right? If it was a loan. Okay, by like $560 almost difference, 562. If they charged monthly interest, it was 65.60. If they were charging continuous, it was even a little bit more. All right, so remember yesterday when I did this problem, I said number 1 is like maybe if you borrowed money from a family member, they would charge simple interest. It would be considerably less. All right, moving on. It looks like we did our trip around the world question. Was everybody? We were looking for an invest today amount. So we were looking for a present value if we wanted $10,000. We could have done this question by just saying it's going to compound monthly, and we're going to leave the money in there monthly for 5 years, and we want $10,000. How would we have solved that on our calculator, guys? What do we need to do to find P? Yeah, we would just take all of this and divide it. $12 times 5 is 60. So it would have still gotten this same 7,600 number, okay? So that wasn't a problem that required the app at all. The only time the app is really required is when you're talking about some kind of payments, okay? Just so you're aware that you have to use it pretty much only if you're using payments. All right, number 5 is something about interest rate of return. Can you find that on your sheets, guys? Gold reference sheets that had formulas. Anybody find anything that talks about rate of return? Yes, says which investment is giving a higher rate of return. The reason, what that is taking 5.2% compounded quarterly or 5.12% compounded daily. Do you understand how those could be really close together? One is a slightly lower rate, but it's being compounded more often, right? So you have to kind of pick and choose which one is going to be better. So I don't have the formula memorized because this is how I think of it. I think if I gave $1 to this guy, he's going to take 1 plus 0.052, quarterly is 4. If I let him have it for a year, it's going to do 4 times 1. And then I want my dollar back so that I figure out how much interest he made on my money for me. That is the formula, is it not? The one out front doesn't matter, right? But that's the formula, okay? And the one up here doesn't. So I just think of what it means, but you can just use the formula. Okay, type that in and see what you get. You don't need any more parentheses than I put in. Make sure your -1 is not in the exponent, though. I typed something wrong. I transposed some numbers. Yeah. And sometimes you got to go out a few places on these because what is happening is the compounding is causing there to be more interest. So it's effectively like 5.3%, 5.302, okay? Now, if we did the other one, compounded daily, again, I would think of it as putting $1 in. It's 0.0512. Daily would be divided by what, guys? 365. To the 365. If I let him have it for a year and then I took my dollar back, we'll see how much he made on this. It's very close. But which one is earning a little bit better interest? Yes, so even though they're only compounding this one quarterly, it does have a slightly better rate of return, is what this is called. So rate of return is kind of what you're actually getting with the compounding. It's a great thing to know, it's very useful, but I don't think it's on the quiz. Well, you can do some payments. Okay, you have your first full-time job and you've decided to start an annuity. Do you remember what that meant?
When you put money away,
For, yes, whatever, yep. To save for retirement, is what this one says. You're going to invest $50 every month for the next 40 years in an account that will provide 6.5% interest compounded monthly. What will be the accumulated value of this account? So what are we looking for? Anybody know? Present value, payment, interest, what are we looking for?
present value.
Yeah.
Future value.
I usually call this future value. Yeah, you could say final value. It's kind of the same difference, but what is N? How many times are we going to put money in? Every month for 40 years, so 12 times 40. I is 6.5, and remember we don't move the decimal over. Present value is 0. We are going to add payments, though, of $50 every month for 40 years. And it is monthly, so we're doing 12 and 12 back there. Okay, how do I get to the app again? Okay, and this was 40 times 12, was that right? Or 480. I don't remember the interest rate. 6.5? 0? I'm only putting away 50 bucks, but my future value, now, you can't come up during the quiz and ask me how to do this. How do you get the answer for this again? Yes, it is the green enter, so it is the alpha button. Had people doing second enter and they couldn't figure out why they weren't getting it. So $114,180.95. Yes? Everybody getting that? Now, why is it negative again?
Because it's counting for the money that you're
Okay.
taking out.
So if I put this in as negative 50, like I'm giving them 50 bucks, when I did it that time, it would come out same answer but positive, right? Just means one way the money's going. Okay, 114,180.95. Okay.
Save for retirement early.
Now, how much did you actually give them, guys?
It would be,
Yeah, 50 times 40 times 12.
about,
Yeah, you only gave them $24,000. That's what happens when you start saving early, okay? Yeah. Unfortunately, I didn't do that. Not a good example for you. All right. Redo this, but with a $100 investment, and you decide you're going to retire in 45 years. And it's going to up to 7%. So N is going to be what? 45 times 12. I is 7 this time. Present value 0. Payments of 100. Future value and 12 and 12. Anybody get, I got 379, 259, and 47 cents. Okay, this time how much did we give them? 45 years of monthly payments at $100 each. We still only gave them $54,000, and it wound up with close to $400,000. Yeah, okay. Start young, even if it's $25 and later you up it to 50 and later you up it to 100 when you can afford it. All right, number 8, suppose your retirement goal is $1 million. So where are we going to put $1 million in? Yeah, we want there to be $1 million at the end of how many years does it say? 50 years. So N is going to be 50 times 12. Because it says, what monthly contribution should we make? 8%, present value 0, but the payment is what we're trying to figure out, yes? How much money do we put in there? So, 50 times, I suppose I should do this on here so that the video catches it, but 50 times 12. Was it 8% this time, guys? Future value is 1 million. Make sure you get all those zeros in there. I got $126.08, yes? Anybody having trouble? Think about that, guys. All I got to give them is $125. I know that sounds like a lot of money right now to you, but... Huh? No. Your car insurance is probably way more than that, especially for your boy. Every month. Depends what you drive for a car, but what kind of coverage you have. All right. You want to borrow $7,000 to purchase a car and pay off a loan over a 5-year period. What is the size of the monthly payment? So what are we looking for this time? payment. And the interest is 6.8. Where's the 7,000 go?
In present value.
Good job. And what is our future value? What's the future value at the end of the loan, guys? 0. We need to make sure we've paid off our loan in 5 years. So 5 times 12 and 12 and 12. All right, so our N is 60, our I is 6.8, which I can't type. Present value is $7,000, but we want to pay it down to 0. So what size payment do we want? Anybody? Okay. Everybody getting that? All right, suppose you can only afford a $250 payment. Or suppose you could afford, I don't know about only. $250 a month is your payment for the next 3 years. So that would be 3 times 12. They're going to charge you 5% interest. How big will your loan be? Where am I going to put my cursor? Present value is how much I can borrow, because what is the future value?
0.
I want it paid off after 3 years, it says. Okay, so this is how much you borrow at the beginning, so that it's paid down to 0 in 3 years. How much can we borrow, guys? Now, just a little adulting question. If that's how much you can afford for your loan, should you go out and look for an $8,000 car? Probably not quite, right? Because there's tax, title, registration, fees, all kinds of stuff. Like a $7,000 car or a $7,500 car at the most. That's what your loan is going to need, unless you have some money put away for those other costs. And then again, maybe you look for an $8,000 car and you try to get the salesman down, right, to what you can afford. But all right, that's the notes. The work assignment that goes with this is worksheet 5. And I do need to talk a little bit about a couple of the problems on worksheet 5 are half-life or doubling questions, and we have not covered that formula yet. Do you have the gold reference sheet? Is it maybe the far right, it says, bottom right? Okay. The half-life or doubling formula. The rate R goes in here, and that's like a 1/2 or a 2 or a 3 if it said it was tripling. And this is the issue for students. It's T divided by the length of the half-life. In other words, let me just make a quick example here. If there were 100 mice let loose in the school, okay? And we managed to trap half of them every day. After 1 day, we'd be down to 50, right? After 2 days, we'd be down to 25. After 3 days, we'd be down to 12.5, approximately, okay? But the idea is that it's only going by halves every 1 day. Like if we said hours or something, it's over every 24 hours, okay? Because it only halves once every 24 hours. Or in the case of these, like you've heard of half-life, like that's why we get scared of nuclear weapons and nuclear power, because uranium has a very long half-life. It stays radioactive for a super, super, super long time, okay? So it's that's the number that goes down here, is the half-life or the length of time it takes to do that. So, and the n sub 0 is just the initial amount. So here's my example. A 50-gram sample, how much of it remains, okay? So 50 grams is n sub 0. After 12 hours, that's how much time has gone by. If its half-life is every 2.5 hours, that's the length of h. And what is r going to be? The r is a half. So it's 1/2, and it's 12 hours, where only every 2.5 hours counts as a half. So then you type it in. 50, you don't use your app, we're on the home screen. 50 is being halved every, and we said 12 hours have gone by, but it's only being halved every 2.5. Thank you, thank you, thank you, thank you. Okay, so there's, after these 12 hours, there's only 1.8 roughly grams of it left.
Like, can you do this with other amounts, like quarter lives?
Yeah,
And then you just change
the 1/2 to 1/4, yep. It also works for doubling, guys. Can you look, I
just
think,
replace
the R with
a
T, yep. Here's the half-life one, it's number 6. This is worksheet 5B, which I think this one is an assigned homework question. So the half-life of a certain radioactive substance is 14 days. If there's a 4,000 grams initially, how much remains after 28 days, 100 days, and when will there be less than 1 gram? Okay, the first two are just typing questions. What is n sub 0? N sub 0 is the initial amount. What's R? This is a half-life again, right? What's T is whatever they gave us in the question here for these two. But the H is the length of the half-life, which is 14 days. So for the first one, we put in 4,000 times 1/2, and it's 28 over 14. Does that make sense, guys? 28 days have gone by, but the half-life is 14, so it's only halved twice, right? So it should be 1,000, shouldn't it? Because it's halved once would be 2,000, it's halved again, which should be 1,000, okay? 1,000 grams. Okay, what about after 100 days? So I'm going to go back and start with 4,000, but it's having, this time, 100 divided by 14. So it's halved a whole bunch more times. 28.3, anybody? Okay, how are we going to do this one? When will there be less than 1 gram left?
You put that
Well, this is what we want to know. What are we trying to find? What variable am I looking for?
wouldn't it be less than
Yeah. What's the variable I'm looking for, guys?
the
Yes. Okay, so what we could do is put this in for y1 and just put a line at 1 and figure out when it falls below. It's the only way we know how to do this question yet. We will eventually learn to do this by working backwards and using a logarithm. But if I put it into the calculator, 4,000, 1/2. Yes, you could do guess and check on this question. It's going to ask you for work on the quiz. You either have to say you did it by graphing or x over 14 was up in the exponent. If you had an older calculator, you'd need parentheses around that. We want to know when it falls below 1. Now, we need to use a little bit of brain power here. What is x representing? The amount of days, right? Did it work to go out to 100? What did we get for 100 days? We still had 28 grams. So it's going to go out pretty far. You want to do at least 200? We can always make it more. Okay. I'm going to just change this scale then because we're counting to 200, so maybe we'll count by 50s or something. Doesn't matter. You can leave the scale 1. Never matters for scale. What was the y value you're trying to get to? Well, it started with 1,000 grams, but we want it to go all the way down to 1. So I'm just going to leave this very low because I'm focusing on when it gets that low. Oop, it works in this window that we did. What did you tell me? 200? Okay. If we had said, I just want to show you guys, if we had said the y is going to start at 1,000 and go down, this is, and it's so close to this you can't even see where it intersects. That's why I didn't bother to start at 1,000. I just said, well, let's focus in closer to the bottom. Okay, it does get there by intersect at 167.5, about 168 days. Is that what you got by guess and check? Okay. 168. Why did I round up? Well, even it rounded up anyway, but it wanted to know less than 1 gram, right? That's a quiz question eventually. We're going to do a lot more applications, but if we have to be less than 1 gram, even if it was 167.1 days, if I ask you to round to the nearest whole day, you have to round up or it won't have decayed enough to be below 1 gram. Yes.
I have a question. Is there a way you can trace to the 1 gram? Like,
You can only get close. You can't get exact. You can trace anywhere you want, but
I meant like A to the Y, like to a Y.
no. You just trace along it. If I did not put this y equals 1 in, Martin's question is what happens if.
Well, no, I meant like could you do something like you type in X equals 1 and then it brings
Yeah, it won't. No, that's why we put it in y2. You can trace here until it goes less than 1 and see about where you are. Okay? Yeah. But to get a more exact answer, we're going to learn eventually to solve it algebraically. I think I can be done and you can work, or I could set. Do you guys have to do 5? Does anybody know? Is 5 circled on yours?
All these are circled. 1, 3, 5.
Okay. Number 5 is a little bit like the one we were just doing. It says the atmospheric pressure is 14.7 pounds at sea level and is reduced by half for each 3.6? Does it say 3.6? Miles above sea level. This rule works for altitudes up to 50 miles. So we're supposed to write in a formula here. So at sea level, the initial pressure, this is n sub 0, is 14.7. And it is, what's happening? What's the rate it's changing by? Half. So that goes in here, but it only happens every multiple of what? 3.6 miles. So it's, should I use A for altitude divided by 3.6? But what is our altitude supposed to be in for units according to this formula? That's what the pressure comes out to be. But right now, the altitude is in miles, right? Because it says this rule works for altitude up to 50 miles. So it says how many feet above sea level is the atmospheric, okay, just start with B. B is easier, we'll come back to A. All right, what is the atmospheric pressure in Denver, Colorado? Anybody know what they call the stadium? Not the fancy sponsor name, but it is Mile High Stadium, so it is 1 mile high, okay? Denver is roughly 1 mile up. So if we put a 1 in here, how many pounds per square inch of pressure is applied at 1 mile of altitude? Anybody get an answer? Yep, about 12.1 pounds lbs per square inch. Okay. Now it says how many feet above sea level is the atmospheric pressure? 4 pounds. I think we have to get our answer in miles and then convert. What do we want to be for? We want it. Yeah, but we don't need that conversion yet. We want the final P to be 4. So 4 equals 14.7 times 1/2 to the x over 3.6. So we're going to graph it. Okay, and we want it to fall below, what did it say? 4? Is that what it was given? Okay, so my window, the window I have, yeah, I know. Okay, X, okay. Zoom 6, perfect, okay. We want the intersection. By the way, if it was an application problem on a test, I would not be happy if you showed me a Zoom 6 picture, because neither of those things can be negative, right? You could do a Zoom 6 on your calculator, but when you wrote it down, you should only show me the first quadrant as an application. All right, I got 6.8, 6.76. Anybody else get that? Okay, so what that's saying is you'd have to be up 6.76 miles to get that kind of low pressure. How do we change that to feet? Well, 1 mile we need to divide by, but that's multiplying by 5280 feet. Some of you know that conversion. Oops. I don't have the number on my calculator, so I got around 35 or 36,000. 35,693 feet. So if you were to climb a mountain that's 36,000 feet tall, you would be at a pressure of only 4 pounds per square inch. I don't have a clue, so. The only other one that's a little weird, this isn't, it's just the way it's set up. Number 1 says the relationship between the intensity of light in lumens at a depth of h feet in Lake Erie is given by this. So it's the log of the intensity divided by 12. And remember, the I is the lumens. Okay? And it equals negative 0.00235 times h, which is the depth. Okay? So this one, you're putting a 40 in here. Oh, we gotta work backwards. But we can do that. How would we solve for I, guys? Negative 0.00235 times 40. If I do the first one, you should be able to do the second one, right? Because it just changes to 100. All right, I'm gonna go ahead and type that in. Negative 0.00235 times 40. Okay, I have the log of I over 12 equals negative 0.094. Did someone get that? Did I type enough decimals? Okay, no. Okay, now what? How do we solve for I? The other formats or the other exponential? How do you write that as an exponential instead of a log? We want to get rid of log. Well, what is the base right now? Okay, remember how it goes? It goes log base b of a number equals p the power. Remember the little video? So what is the b right down here? It's log, so it's base 10. So it's 10. So it's base to some power equals the number, right? So it's this base to the power of equals I over 12. 10 to the negative point. Oh, I left a 0 out. Sorry. The decimal's here. I got 0.80537. And then what would I need to do still? Multiply it by 12. So I got the intensity. How do I label that intensity right here? .66 what? Lumens, yep. All right, so you need to repeat that, but you need to use 100 instead of 40, and then you'll be done with that problem. And I'm going to be done for the day because I feel like I've done half your homework. Did anybody, though, have a question on anything on the homework? Because you are coming up on a day of getting ready for a quiz without me here. Yes. What's your question? Lost my tablet. All right. So would this be 21 years, right? The cost went from an initial value of 119. It was growing by some rate. In 21 years, it became 391. So we got to work backwards and find R. Is this what you did?
Yeah.
391 over 119. Yeah, I gotcha. So then we'd have to go to the 1 over 21 power, right? To get rid of that. And then we'd subtract 1. Okay. So 3.91 divided by 1.19, then all of that to the 1 divided by 21 power. I have 1.05828, 1 plus R, so the rate is 0.0583 maybe? Did you go that many places? Okay. Well, you're gonna get a different answer probably than I would, okay. It says, when will the cost of gallon of gas average $7 or exceed 7? So if we started at 119 and it was going up 1.0583, and we want to find out how many years until it is greater than 7. So you'd probably have to do it as a graphing question, because we haven't figured out how to do that otherwise. 119 times 1 plus 0.0528, okay, 83, okay, we'll go. And then to the X, and we want to know when it exceeds, what is it, $7? Okay, so we need the window to go up 10, which it does, but this one's gonna have to go out probably a long time. Okay, they intersect at 31.3 years. So like 32 years, because you want it to exceed that. So maybe 32 years. Okay, better?